Hello everyone, welcome to today's video on remainder and factor theorems. So the formula for remainder theory is that for any polynomial p of x, we have a function q of x which is called the quotient, and L of x, the linear divisor, plus remainder. So we'll say that this is a polynomial and this is the quotient, and this is the linear divisor of the form. This guy is of the form ax plus b, where a and b are constants, r is the remainder, and p of x is the function that were the polynomial. So for instance, if we are to divide, let's say, ax squared plus bx plus c over x minus k. If we were to divide it, you see that here a is 1 and b is minus k. So if we were to divide it, we will just do it like this. So let me put it in red so that we have ax squared plus bx plus c divided by x minus k. So we find out that the first thing that will go there is ax, so that this times this will give us ax squared, this times this will give us minus akx, so that we have this and this will cancel. This will be bx minus this is plus akx plus c. That's what we have. So the next thing that will go is plus b. So b here will give us bx plus bk, and that is minus bk plus minus bk. And that's all. This minus this will cancel. This minus this will give us okay, if we like, you can write it as akx plus bk plus c. That's what it will give us, plus bk plus c. So the next thing that will go is, if we look at here, is ak plus ak. So plus ak into here will give us akx. This into this will give us minus ak squared, so that we have this, we cancel this, bk plus, that's minus this is plus ak squared plus c. So you find out that this implies that our p of x over x minus k is equal to this is the quotient ax plus b plus ak plus remainder, this is a remainder, plus plus ak squared, if you like, plus bk plus c all over x minus k, So from here you can see that if we now open up there, if we open up here, p of x will be, if we multiply it through by x minus k, sorry, if you multiply it through by x minus k, we have that this is equal to, is equivalent to this ax plus b plus ak times x minus k plus remainder, AK squared plus BK plus C. So you see that our Q is equal to this, and our LX is equal to the linear divisor, and our remainder is equal to that. So that is how to do it. So for instance, let's assume that we are asked to divide x cubed plus 4x squared plus 3x minus 1 by, let's say, x plus 2. If we are asked to do that, so we'll set it up like this, and say x plus 2, then here is x3 plus 4x squared plus 3x minus 1. So that we have that here will be x squared, and we have x3 plus 2x. Good. So this and this will cancel. This minus this is 2x squared. 2x squared plus 3x minus 1. The next thing that will go is 2x plus 2x. So 2x into here will give us 2x squared plus 4x. This times is 4x. So we have this and this will go. This and this will go. So here will be minus x minus 1. So the next one will be minus 1. This into this will give us minus x. This into this minus 2. So we have it to be 0. This and this 0. This and this minus 2 is 1. So it means that minus 1 is our remainder. This whole stuff in the bracket is our quotient q of x, and this one that we divided is our L of x. That is the linear divisor. So that is how to do this. So factor theorem is just a factor theorem when r is 0. When r is 0, factor theorem is a special case of remainder theorem when r is 0, when r is equal to 0. So we can even use it to connect the factors with the roots of the polynomial. So the remainder theorem connects the factors with the zeros of the polynomial. So for instance, let us factorize. For instance, factorize x cubed minus x squared minus 14x plus 24. So what we have to know here is that there will be 3 roots. Because of this, there are going to be 3 roots. So, and this can be, if we find the lowest common multiple, there is 2 there, there is 4 there, there can be 6 there can be 8, and what have you. So but in order to do that, we say let p of x be equal to p of minus 2. If if this p of minus 2 gives us 0, then we know that minus 2 is a root. But if it doesn't give us 0, we know that it is not a root. So if we do it, we do minus 2 raised to power 3 minus 2 raised to power 2 minus 14 into minus 2 plus 24. So we will now have that this is minus 8 minus 4 plus 28 plus 24. This will give us around 40. So minus, therefore minus 2 is not a root. Okay, let us try p of x is equal to p of 2. So if we try it, it means that we are going to have 2 cubed minus 2 squared minus 14 into 2 plus 24. So we have 8 minus 4 minus 28 plus 24. So this minus this is minus 32, this plus this is 32. So we have 32 minus 32 is equal to 0. Therefore, 2 is a root. 2 is a root of that polynomial. So if 2 is a root of that polynomial, we can now use this. That means, and okay, 2 is a root of the polynomial, and x minus 2 is a factor. And x minus 2 is a factor. So if x minus 2 is a factor, that means that we can use this to divide our polynomial. If we use it to divide our polynomial, minus x squared minus 14x plus 24, we can use it to divide our polynomial in that way. So here will be x squared, so that we have x3 x cubed minus 2x squared. So we have this and this cancel, this minus this, that is x squared. That's x squared plus 2x minus x squared plus 2x minus 14x plus 24. The next thing we'll do is to get this, so we add x here, x squared, x here minus 2x. So we'll have this will go minus 14 this, does give us minus 12x plus 24. So the next thing that we go is minus 12 times this minus 12x minus 12 times this plus 24. So there is no remainder. This will cancel this, will cancel this. So remainder is 0 and this and that. So that means that we are going to have, that means we will have that p of x, that means that our p of x is equal to q of x plus L of x plus 0, where this guy is the remainder is 0. So we have that our q of x, which is the quotient that we got, is x squared plus x minus 12. The linear stuff is the root, one of the factors that we got, which is the factor that we got actually, which is x minus 2. So it now remains to open up this one. There are various ways to open it up. You either do a root of it, because this is going to be 2 roots to add to this one to make it 3. So it will either be 6 and 2, 4 and 3, and 4 and 3 should be about the best thing. So let us do it by analytical method. So you know that this is going to give us x squared plus the 4x, okay, let's say minus 3x plus 4x minus 12. That's what it should give us. X minus 2 is there. So this one will give us x into x minus 3, x into x minus 3. This one is 4 here, plus 4. So that we have x plus 4 and x minus 3 this to be the roots. So this one is the same to give us the root. So x plus 4 and then is 0. But if you are asked to do it through the remainders theorem, all you have to do is to put, because it means that minus 4 will be a root. So if you say minus 4, that means it's going to be from here to be minus 4 squared plus minus 4 minus 12. So that is 16 minus 4 minus 12, and that is 0. So it is a root. Also, p into 3, which is supposed to be a root. So we will have in here, it will be 3 squared plus 3 minus 12. So we are having 9 plus 3 minus 12. That is 0. It's also a root. So that is the link between Remender's theorem and the factor theorem. And it's very good because when you have a remainder that you want to resolve into partial fraction, it will be easy to get out the quotient first and now resolve the one in the other remainder in partial fraction. Thanks for watching the video, and please subscribe and click on the notification button to alert you whenever we post new videos. Bye.